Okay, so let's try another problem that's using the distribution of the sample means. And this one is also from that same book. It's called Biostatistics 8th edition by Wayne W. Daniel. And this problem here is about uric acid levels. So we're going to say that the uric acid levels in males is about normally distributed with a mean of 5.7 milligrams per cent and a standard deviation of 1 milligram per cent. And find the probability that a sample size of 9 will yield a mean that is more than 6. And then we'll try between 5 and 6. And then we'll do less than 5.2. Alright, so this is similar to the previous problem that we did. I like to write down the things that I know. And so far, they told us what the population parameters are right here and right here. So we may as well draw that out. So here we have our population distribution, and we said that it's about normally distributed, right? Because I said that here. And that's important because we're going to be taking small sample sizes. And when you take small sample sizes, then the population distribution does make a difference. When you take big ones, like things where you take sample sizes of greater than 30, then it doesn't matter because eventually the randomness of it all is going to make that sample distribution that we're eventually going to form over here. It's going to make that normally distributed. But if you use small ones, it doesn't work so well. So that's why we're going to start off with a normally distributed population because our sample size is less than 30 because it's 9. Okay? And so now we know, the second thing that we know is that we're going to be taking a sample of size 9. So let's do that. So remember, we're going to be taking a random sample of size 9, and then we're going to get our little sample distribution over here. And our sample is going to have a mean of x bar and a standard deviation of s. Okay, and so now we're asking, what is the probability that this mean here is going to be more than 6? So remember, we can take this mean and we can dump it into a standard distribution of sample means. So let's do that. So we took our mean and we put it in this distribution. We're getting means from all sorts of all sorts of samples of size 9 and putting it in here. And we know some stuff about this, right? Because we already know that the mean of this thing, which we're going to represent by mu sub x bar, and that's going to be, by the central limit theorem, if you take enough of these, it's going to equal the same thing as mu, which we said was 5.7, right? And we know something else. We know that the standard deviation of this, which we also call the standard error, is equal to the standard deviation of the population over the square root of n. And we know both of those numbers already. We know that's 1 over the square root of 9, which equals 0.33. So now we have all of these values for our sampling distribution. Now, armed with this, we can answer these questions here. And so, let's do it. So A says we want to have it be more than 6. So that distribution, that sample mean we're going to have, we want it to fall in this area right here, right? So that's more than 6. So now we can convert this 6 into a z-score. So let's go for that. So we remember that z equals the value we're looking at minus the mean, in this case mu sub x bar, over the standard deviation, which in this case is the standard error. And so here we know the value we're looking for is 6 minus the mean, which is 5.7, and we're going to divide that by 0.33, and this equals 0.9. I mean, this really wasn't 0.33, it was 1/3, and if you do the math, you get 0.9. So now this just becomes a simple z-score problem again. So let's do that. And so here's our distribution, the z-distribution with the mean at 0, the standard deviation is 1, and we know that we said we wanted to get to 0.9, so 0.9, and we wanted everything that was above that value, right? Because we had said in our other one we wanted a value greater than 6, and we calculated 6, the z-score to be 0.9. Great. So now all we have to do is find 0.9 in our z table. And so we got 0.9, and it's right there. And we want 0.900, so there it is, 0.8159. That's the value we're looking at here, right there, 0.8159. So what that means, though, really, is that this here really is this represents this area here. That's 81.59% of the area. And so that's not what we want. We don't want this area. We want this area. But we know that the area of the whole thing is equal to 1. So, and we want to remove everything except this part, and we know this part. So it's 1 minus 8159. So the math becomes pretty simple. And so this then becomes, using a calculator, 0.1841 or 18.41%. So the probability of the mean being greater than 6 is 18.41%. Great. So that answered our first question. Now let's do the second question. What is the probability that the mean falls between 5 and 6? So we want it to be between here, 5 and 6. So why don't you pause the video here and see if you can figure that one out, and then unpause it and we'll go through it together. All right, go. All right, let's see what we got now. So we got 5 and 6, so we got to calculate two z values here, the z for 5 and the z for 6. And so let's do the 5 one first. So we remember that the formula is the value minus the mean. So that's the formula. So let's first do it for 5. So we get the z for 5 equals 5 minus, and the mean we said was 5.7, and we're dividing it by 0.33. Really, it's a third. And then the next one, we're going to do it for 6 at the same time. So we get 6 minus 5.7 divided by 0.33. And now let's calculate these. So this is going to be minus 0.7. I'm going to say a third, over a third. And this one's going to be 0.3 over a third. And so if you do the math, and it's actually not that difficult, because 1 over 3 means you're just going to multiply this by 3, and so this answer is going to be negative 2.1. And for this one, you can flip that 3 up there too, and we already calculated this one actually in the first part of this example, and that equals 0.9. So now we're ready to go with the z-tables. And you'll remember now, we'll put our z-scores on this z-distribution here. The mean we know is always 0, the standard deviation is 1, and we said we want our values to be between the z-score of negative 2.1 and 0.9. And so what is negative 2.1? What's this value here? We can calculate that over there, the other side, right? This area in here. And what is that? Well, let's find negative 2.1 in our table. It's right there, negative 2.1, and it's a negative 2.100, so we know it's going to be this here, 0.0179, 0.0179. And we remember this from our previous value, and that value we said was 0.8159. And so now we know that we want to subtract off this pink area from this green area to get the total purple area. And so we're going to subtract this number from that number. And then we get 0.8159 minus 0.179, and that equals 79.80 or 79.80%. So that is what the probability is of having a mean between 5 and 6. So I hope if you did it on your own, you got the same value. If not, go see the way that I did it. Now let's do the last one. We want to know if of getting a mean of less than 5.2 when we have a sample size of 9 and these values here. Go ahead and try it yourself, and then pause it, and I'll be right here. Okay, so now let's try it. Okay, so we want to have a value that is less than 5.2. So let's put that up here. And so we know that it has to be less than that. And so what is the chance that this is going to be less than that? Well, we can calculate the z value for this as well. So we know our formula, it's up here, right? We have this still from before. Let's fill in the values. So our x now is going to be 5.2. That's the value we're trying to calculate. The mean we know is 5.7, right? And the standard error is a 1/3. Okay, and so now what are we going to get? Up at the top, we're going to get negative 0.5 divided by 1/3, and that's going to equal negative 1.5. You could use a calculator to do it if you want, but you don't really, right? Because you know this is 1/3, so this 3 comes up here. You multiply negative 0.5 times 3, and you're going to get negative 1.5. All right, so now we go back to our z-tables, and we'll figure this out. And so here again we have our z distribution, and we know that the z-score we wanted it to be less than was negative 1.5, and so we want this area right here, and so that's easy. We just find negative 1.5 in here, and there it is, right? There's our negative 1.5, and we know it's negative 1.500, right? So we're going to use this here, and that's the value that we're going to get. This area here is equal to 0.0668. And that's exactly what we wanted to calculate. We're not going to have to do any subtracting or anything like that. So really, this is also equal to 6.68%. So having a z-score of negative 1.5 being less than that, so about a 6.68% chance of that happening. And so here are the answers to our problem here. For more than 6, 18.41%. To have it fall between 5 and 6, 79.80%. And to be less than 5.2 is 6.68%. Those are the probabilities that we would have given this information here. So good. This is another example of how we're going to use sample distributions of the sample mean in order to calculate probabilities of getting certain values, of getting means of a value, in this case, uric acid levels. If you have any questions, please put them in the comments below. Otherwise, I'll see you in the next video. Thank you and bye.